But no matter what, you're going to have some confirmation latency, and someone could always try to beat the oracle to reporting that. So you got to build some level of acceptance of latency somewhere into your protocol to safeguard.
You can only put so much information on a blockchain transaction, right?
Yes, I think you're limited to 1232 bytes because it's size of, well, it was UDP peg, and now Quick I think has some other denominations it uses.
Yeah, I thought they were extending it or increasing it at some stage.
You can only do it to a certain point.
Right.
But they, another great feature they're having is those account mappings, which, when you have a data feed, we have like 5 or 6 accounts. One's the escrow, one's some other metadata stuff for like when it can be updated. Essentially, we have the account types for the aggregator, what we call a lease to manage the payment methods for the aggregator, and the escrow. We don't need to take up the limited, I think it's some 20-something accounts you need to pass in a transaction with multiples of 3 for each of the accounts we need. So they have this new feature that is account mappings, so you could more tightly pack these, and it's really useful for what we have is something called a crank system.
Right.
Also, so when you actually have a data feed, it automatically updates every 5 seconds. How does that actually work? We actually do all scheduling for data feed updates on-chain. So we have a gigantic priority queue that have a timestamp linked with an aggregator pub key. So we just have to guess what's at top when the transaction actually lands, because we can actually predict it by the time we're formulating our transaction. Because if you know in Solana, you need to know exactly which accounts you're going to be touching right at the start of your transaction. Yeah.
And that's one of the things, right, with the cranking as well, that like if there is a source of a data feed that maybe people know what the source is before it actually gets published on chain, and then the crank runs, like things can only update on chain once the crank runs, but people might be able to front run it kind of thing by sort of knowing the source in advance, right? So is there any sort of, I guess, things that people need to be aware of when running data feeds?
Well, people should always check and tolerate a certain latency. There's going to be no oracle that can just stream as fast as the sources. So right now we're have a lower bound. So the way that the whole flow works is you have one transaction for the crank to call that new information should be pulled. That gets launched to a set of oracles. They take some time to fetch HTTP responses or whatever type of responses you want, which we have a timeout of 2 seconds, and then they have a response. So the lower bound is the confirmation time of 2 transactions plus 2 seconds.
Yep.
So that's the lower bound of this poll system that we made with Switchboard. There are other ways where you can just stream information directly from a WebSocket into some aggregator, which we are currently designing because we've had a few requests for it.
Yep.
But no matter what, you're going to have some confirmation latency, and someone could always try to beat the oracle to reporting that. So you got to build some level of acceptance of latency somewhere into your protocol to safeguard.
Yeah, exactly. I think apps have got to be aware of that.
Yeah.
And pretty much, I mean, most apps probably have some sort of tolerance in whatever they're trying to do. It would make sense to do so.